So we're going to continue talking about capillaries, and this time we're going to talk about regulation of capillary blood flow. So we've got three outcomes for today. And so I want you to take a look at this figure that we've got over here to the right. Okay, and so we've got on the x-axis, we've got pressure. On the y-axis, we've got blood flow. Now notice that it says cerebral, so this is talking about the brain, but this is actually something that happens in a lot of areas in the body. So notice that even though pressure goes up, flow stays relatively constant, and we call that constant flow autoregulation. Okay, and so autoregulation is just the ability of an organ, and usually this is like in the brain, kidneys, among other places, to be constant despite large fluctuations in pressure. And when we say perfusion pressure, that just means the pressure caused by the blood. Okay, but the heart, brain, and kidneys are where this primarily occurs. And we're going to go into a little detail during week 12 of how this actually occurs in the kidneys and the importance of this autoregulation. Now, the way that this autoregulation is able to occur is through something called the precapillary sphincter. Okay, and so here we've got an arterial, here we've got a capillary, and then here we've got this band of tissue that's called the precapillary sphincter. Okay, and we're going to go off the assumption that you all know what a sphincter is. Okay, it's just an opening or something that can open or close to allow flow. All right, and so if we've got low pressure in the arterial, which would mean low pressure coming into this capillary, that's actually going to cause the sphincter to open up. Okay, so low pressure opens the sphincter, so that'll increase blood flow into the capillary and increase the amount of blood that goes there. All right, now if we have high pressure, we're going to decrease this, or this sphincter is going to close, which will decrease blood flow. And especially in the kidneys, especially in the brain, especially in the heart, we need a specific amount of blood so they can complete their functions. Because if blood pressure is really high, blood's going to be moving so fast that gas exchange can't occur, and we don't want that. All right, so when it comes to arterioles, they can vasodilate or vasoconstrict. And so it might have been a little misleading to call this capillary blood flow, but the arterioles are ultimately what supply the capillaries with blood. Now, vasodilation isn't generally something that happens actively. And what I mean by that is that vasodilation usually happens when we get rid of hormones that cause vasoconstriction. So, for example, as you talked about in lab during week 8, epinephrine causes vasoconstriction in arterioles all throughout the body. Well, if we get rid of epinephrine, that allows those blood vessels to relax, or in other words, they dilate. However, there are some hormones that do cause vasodilation. Okay, and so here we go. Now, you're like, wait a minute, you just said epinephrine causes constriction in the systemic vessels, and that's true. The exception is the coronary vessels. And so if I've got a fight or flight response, that means my heart's going to have to work harder, and so epinephrine actually dilates my coronary vessels. Acetylcholine causes vasodilation to allow erection to occur. Nitric oxide actually dilates blood vessels. This is something that happens during exercise. And just the fact that you've got low oxygen will cause increased blood flow. Okay. When it comes to vasoconstriction, we've talked about epinephrine. Norepinephrine also causes vasoconstriction. Vasopressin, which we'll talk about I think in 2 lectures. And then when we get back into the kidneys, will increase blood pressure, and so what it does is it allows us to hold on to water. And then angiotensin II will increase blood pressure if we have low salt, and this will cause us to hold on to salt, which will pull fluid in, that sort of things. Okay, so this is just kind of a big broad overview. We'll get more specific, especially with vasopressin and angiotensin II later. So short and sweet, right? So here are 3 things that I hope that you can do after watching this once or twice. So there you go.